In this video, we're going to talk about the branch level controls. Here we have a Delonix tree from the tree library. What I want to do is talk about the parameters that we have in branch level 1 that are also available all the way up to branch level 5 in this case. The reason we have 5 branch levels is because the tree has 5 render levels. If we set the render levels to 3, for example, then we're going to get 3 branch levels and so forth. I'm going to set them to 4 and set the viewport levels to 4 as well. The viewport levels dictate how many levels are displayed in the viewport, while the render levels are the levels that are going to render. So if I set my viewport levels to 3 and give this a render, then I will get 4 levels rendered. If I set the render levels to 5 and give this a render, of course I'm going to get 5 levels rendered. If I uncheck use render levels, then you're just going to render whatever viewport levels you have over here. So again, I'm going to set the render levels to 4 to be able to work more easily with the tree. If you go to branch level 1, first we have the insertion count. If I set my insertion count to 1, then 1 branch is going to be inserted at the first level. This does not affect the other levels like branch level 2, 3, and 4. Of course, I can increase that to whatever number I want. I'm gonna restrict the viewport levels to 1 to focus more plainly on the branch level 1. The first thing I'm gonna do is set my swivel value to 180 degrees. What this will do is flatten out the branch emission to a plane. I did that so I can talk about the insertion bias. I'm going to increase the insertion count, say to a value of 100. So now we have 100 branches emitted at level 1. I'm going to lower down the prune parent to 0, which means that the branches are going to start emitting from the base of the trunk. Also, I'm going to scroll down and I'm going to reduce the turbulence so I would have straight branches. Also, I'm going to go to my trunk parameters and I'm going to reduce the trunk turbulence so I have a straight trunk. That way I can really focus on the way the branches are emitted. So I'll go back to branch level 1 and these are my inserted branches. The second parameter that I have is the insertion bias, which I can decrease so that more branches are emitted towards the top of the trunk. If I increase that value, then more branches are emitted towards the bottom of the trunk. The branch count is still 100, but I have more concentration towards the base of the trunk. Now, in case I changed my swivel value, then I will see the density properly displayed for these branches. The next parameter is the offset from trunk tip. If I increase this value, I'm going to offset the emission from the trunk tip. To see that properly, I'm going to set my spread angle to 90 degrees and the point to tip, I'm going to set it to 0. What this will do is have the branches spread out with an equal angle of 90 degrees. They will not point towards the tip of the trunk. This is what this parameter is doing, point to tip. If I change the offset from trunk tip, this is what this parameter is doing. It's offsetting the emission from the trunk tip. The next parameter is the offset branches from trunk, which will spread out the branches from the trunk in case I wanted to do that. Prune parent will have the branches emit away from the base of the trunk to get a more natural tree appearance. The next parameter is the swivel angle, which is the rotation of the branches along the trunk. If I set it to 0, it means that all the branches have the same angle with respect to the trunk. Increasing that value will actually swivel out the branches across the trunk like this. This goes hand in hand with the point to tip. Before I go to the point to tip, I'm gonna increase the swivel vary, and this will add randomness to the swivel value. So if I set this to 0, you see what the swivel vary value is doing. The point to tip, as we have seen before, will point the branches towards the tip gradually like this. Combined with the swivel angle will give you the proper orientation for the branches. Now, in case you get a visible pattern, then you would actually change the value until the distribution is more randomized, and also you can increase the swivel variance value for more randomness. So if I regain a swivel value of 0, I want to talk about the point to tip bias. If I reduce it, then I get this type of orientation, which means that more of the branches are pointing towards the tip. If I increase this value, I'll get more of the branches pointing towards the spread angle value, which in this case is 90 degrees. So this gives you extra control over the way the branches are pointing towards the tip. Spin branches will spin the branches around the trunk like this. Orient to trunk is very important. If I go back to the trunk parameters, and here I increase the trunk turbulence to a large value and then increase the trunk turbulence scale. So we see that now the trunk is no longer vertical. Also, I'm gonna reduce the fade turbulence at top so that the top of the trunk is no longer vertical. So if you go back to branch level 1, we see that the orient to trunk will actually orient the branches to the trunk like you see over here. So if I reduce this value, then the branches will stay with the vertical orientation regardless of the orientation of the trunk. So with orient to trunk, you're going to get the branches displaying like this. If I increase the branch turbulence and the turbulence scale, and reduce the amount, say to 25, I will start to see what this parameter can do. If I increase the viewport levels to 2 or 3 or 4, here I will see clearly that the branches are not oriented with the trunk orientation, but they are still pointing towards light, which in this case is the vertical direction. Let's change the color of the leaves to something greenish. So if I take the branch level 1 and increase the orient to trunk again, I'm gonna get this type of tree. So in both cases, I'm gonna get a nice, beautiful tree, and the orient to trunk is an important factor where the branches do not take the orientation of the trunk into consideration. The spread angle, if I set it to 0, it means that the branches will not spread at all, but in this case, take the vertical orientation. By increasing the spread angle, you spread the branches over the trunk. And you can vary the spread so that the spreading is not uniform. Now the branch tilt is an important factor, but in the case of the first level is not very significant. So I'm gonna set it to 0 for now, and I'm gonna regain, if I go to my tree library, the Dillonix tree, and I'm gonna set my viewport levels to 2. I'm going to go to branch level 2 because here I'm going to work with the branch tilt value. First of all, we see that under branch level 2 we have horizontal branches, while in branch level 1 we don't have this parameter. The reason for that is because if I increase the horizontal branches, it means that the branches are going to be flat and oriented horizontally. For this to work properly, I'm going to set my swivel value to 180 degrees. And this will give me the proper horizontal feel of the branches, except for the fact that they look vertical. For this, I need to spin the branches 90 degrees. So that's what I have at this stage. To make this clearer to see, I'm going to set the turbulence of level 1 to 0. So I can clearly focus on the branch tilt value and what it's doing. Also, I'm going to increase the insertion count for branch level 2 to 20. Also, I'm going to reduce the turbulence to 0. So now we see that we have a palm-like emission of the branches. So horizontal branches will make the branches have a horizontal orientation, and the branch tilt will actually tilt the branches down or up. So this is what the branch tilt parameter is doing. The default is 0, and you go from 0 up or down. So if you go to a positive value, you're going to tilt the branches up. If you go to a negative value, you're going to tilt the branches down. Combining this with turbulence, you're going to get a very natural orientation for the branches. Now, if you go to the branch global, we have the branch tilt ratio. If I increase this value, it means that the branches are going to be tilted towards the base of the parent branch and less tilted towards the tip of the parent branch. So if I increase the branch tilt ratio value to 1 and I increase the branch tilt or decrease it, you see that the start branches are having this tilting effect at a more intense value, while the tip branches do not have this effect because of the branch tilt ratio, which I can control from here. Since this is controlling all the branches, it's found under branch global, and it's a global parameter for all the branches.